Hi, welcome to the new episode of S Persistent with C++ and Qt. I don't remember the number of the lesson, but I think that is the 38 or 36. Um, so the point is that in this video we're going to talk about the forward chaining algorithm, and if I remember as a teasing for you is that I won't show every instruction, every statement of the forward chaining. I would like you to try to develop this algorithm, especially because it's very difficult, and I think that is a good challenge for you. So instead of that, I'm going to just show the high-level implementation of the forward chaining, and I would like to explain with a kind of pseudo code. I would like to show what actually is doing this function. So forward chaining, what it does is to infer for every rule that we have in the knowledge base, and additionally they're doing a lot of stuff with the containers. It is inferring the different way for the consequence or the antecedents, differing of the modus ponens, the modus tollens, and so forth. So you can see that we have a log only for functions through the test. Conclusion found. This is important in several occasions. It's low level kinda, and we also have a loop for all the rules. It's going to stop until we find a rule of we haven't inferred any rule in the selected section of the knowledge base. So you can see here that we are determining if the size is the same of the inference rules. So if in one cycle the inference rule hadn't changed from the old inference rule amount, it means that we hadn't inferred anything, so we don't have nothing else to determine, nothing else to show to the customers. We hadn't inferred anything. We got stuck, and then it's not correct to continue with the loop if we were not able to do anything. So we stopped by knowledge exhausted and returned, right? And therefore, this is the main function. Is iterate rules. Is iterating all the rules. If there is no conclusion found, is continue the inference process. Well, this is in the main view. This is the forward chaining. As I said, is iterating all the rules, is inferring the correct rules depending on the modus ponens or the modus tollens. It's setting the inference rules containers. It's doing a lot of stuff that we are able to see here in this pseudocódigo. Is it forward chaining log only for function while forever. We're going to set a new inference rule to compare if we infer something new or not. We iterate rules that is going to, per rule, we call it current rule, we infer that rule that if we hadn't inferred, or is it a irrelevant rule. Remember that irrelevant rule is one that is not adding something important to the theme that we selected for. So for example, if we have automobile is persistent, and we have that we want just to focus in the engine stuff, and we have we reach a rule related with breakage or the transmission of the power supply. We don't care about those themes, so we just skip it and we call it irrelevant rule. If it's not inferred or it's a irrelevant rule, then we just skip it. If it's not one of them, if it's modus ponens, we infer the antecedents. If it's modus tollens, we infer the consequences. That's the definition of the modus ponens, modus tollens rules. And if we infer, I think that is the same process, but with different containers and with different values. So in the big picture, in the big view, we have enough process antecedents value to emit atom value demanded. for each antecedent value we emit the current demanding value. Okay, the emission of a value, it's a Q feature, it's a Q characteristic that it says that it passes the certain value to the UI in this case. So we are in the low level part, we are in all the algorithms, all the behavior is processed, and obviously we need to separate that algorithms to the UI. So what we did, what is easy to do in Qt is to emit the value, pass it to the UI. We haven't merged that stuff. This is a good programming practice. So I think that I would like to discuss about the mission later. I think that I did in previous videos, but just a review. So you already know eval, determine if antecedent is present. We pass it to rule and we infer. This is the part that we infer, and then we append it to the inference rule to not check it here, to not do again the inference rule. Remember that if we infer 2 times is not optimized. If we change the value of already inferred no, I don't know, maybe atom, and we are lying because we are saying, no, you have cancer, but a few minutes later we say, oh, you don't have cancer. So it's not correct to do that. For modus ponens, it's pretty much the same. Instead of doing the antecedent, we do the consequence, we emit, eval, and determine if consequence present. Pass it to the inference rule, infer, and append to inference rule. We can merge the inference rule, it doesn't matter. After that, if we found a conclusion, we prompt that the conclusion was found. If it wasn't found, we continue with the inference process. I think that I upload a video where I show how to use the make links, and the user is able to select if he wanted to continue the inference process or he is okay with the conclusion that we reach. And then if continue with the process, we returned, we start again. Wow, what happened here? Okay, forget it, something in Linux failed. And so the last step is that inference rule. If we hadn't infer any rule, then we stop because the knowledge is exhausted. So I'm going to rebuild. While explain, I will pause the recording. So this is the Q documentation where they are talking about the signal and the slot. An error. Great. It's gonna. I don't know what's the error. Inference can. Oh, okay. Okay. Signal slots. It's change. Usually we in the past we use the callbacks functions, and now in Qt we are able to use signal slots. So in the callback function you use a function or a function pointer to pass a value between modules, between functions, or what have you. So here it says callbacks have 2 fundamental flags. Firstly, they are not type safe. We can never be certain that the processing function will call the callback with the correct argument. Secondly, the callback is strongly coupled to the processing function, since the processing function must know which callback to call. So instead of using callbacks, we are able to use signal slots. This is a cool diagram that we have an object. In this part is the inference kernel. We have in the UI this function, the connect, that it passes signal to a slot of object 2. Again, a signal of the object 1 is passed to a slot of the object 2. And we can do a lot of stuff with this. It's a really brief theme that you need to study a certain time. So I think that we have a small sample here. This is pretty much the same. The thing that I changed here is that we have the signal in the declaration of the counter class, and we have the slot. And this is what we did in our implementation of forward chaining. We admit that a value change, and if we pass the value that it changed, after that, what we are going to do is to connect the signal of the inference kernel to the UI slot. So we connect a signal to the slot. I think that's it. You can go there in this file and check whatever you want, but in general it's just that. So I think the rebuild. Maybe I might want to advance, and we're going to talk also for the word chaining. That's the way that we focus. We set a limit amount of rules that we care about. We can have different sections, divide all the knowledge base to I don't know, maybe engine, transmission, brakes, suspension. I don't know where you want. And in this way, we're having a real fast inference process, and that's cool. So we run the application. I already have a test unit of forward chaining. Those are a lot of calls inside of the forward chaining. Don't bother about it. And the thing that it makes sense is that it passed the forward chaining. Let me see. Forward chaining. There are a lot of them. Imagine all the functions that we're going to call if we have a big knowledge, a huge knowledge base. In this knowledge base, we have only 4 rules. Imagine we will have 100 or 1000. It's going to be crazy. Forward chaining rules. Yeah, we have a lot of them. If we go to the test unit, we have that we just set in the forward chaining rules, and that's it. So I hope you enjoyed this. As I said, we're going to continue the forward chaining, and I hope that we finish with that, and we're going to move to the UI queue. So that's going to be very amazing. So see you.